In this video, we're going to talk about the security market line, SML, and use it to calculate required rates of return of the stock, RI. Okay, security market line uses the same equation as capital asset pricing model, CAPM. Stock return, RI, equals risk-free rate plus market risk premium, market return minus risk-free rate multiplied by beta. Okay, so we replace this difference in the bracket, RM minus RIF, by RPM, okay, which is representing market risk premium, okay, RP, risk premium of M, market. Okay, we can use MRP to stand for market risk premium. We can also use RPM. Okay, so this is exactly the same model as CAPM, but we call it security market line because we're gonna draw the line for different stocks in the market. Okay, assume the yield curve is flat and that risk-free rates, okay, RRF are the same, 5.5% for all the stocks in the market. And also market risk premium, RPM, which is market return minus risk-free rate, it is also constant, 5% for all the stocks in the market. Okay, so if we want to calculate required rate of return for different stocks, we can just use the stock, the risk-free rate, 5.5%, plus the market risk premium, 5%, multiplied by beta of each assets. Okay, so for the 5 assets here, we know the 5 betas, so we use this security market line or CAPM model to calculate their stock return, and we have these 5 numbers here. Okay, and for the stock return we estimate from the model, we call it RI. Okay, and we say this is the required return of the stock, or CAPM estimated required return. Okay, these 5 numbers are estimated by using the model, the required return estimated from SML or CAPM. And we compare these model estimated required return to R hat, the expected return. Okay, remember how we calculate R hat? We use the expected return of the assets in each economy scenario multiplied by probability in each scenario to get this R hat. This is the true return based on enough information in the future. Okay, if we know exactly what the stock returns are gonna be in the future in each different economy scenario, we can get this exact expected return easily. Okay, but if we don't know enough information about the future expected returns, the only way we can do is to use SML, okay, or the CAPM. We run regressions using historical data. We get the beta first for the assets, and then we use the estimated future risk-free rate and market risk premium and the estimated beta to calculate the model estimated required rate of return. Okay, so these two returns are different. One is estimated from the model, another one, R hat, is the true return. Okay, and we say R, the estimated return from the model, is going to converge to R hat, the true return. Okay, that's why when R is lower than R hat, in the case for high tech, we say high tech is undervalued because we think the estimated return R is gonna converge to the true return R hat. Okay, R is gonna go up in the future. For the markets, R hat equals R, so we say it's fairly valued. For US rubber, the model estimated return R is going to converge to the true return of the asset. Okay, it's going to go down in the future, so we say it's overvalued. Okay, and we can illustrate this security market line on this graph here. Okay, this is the security market line. We use beta as our x and we use Ri as our y. Okay, and we know Ri stock return equals risk-free rate 5.5% plus 5% multiplied by beta for any asset. Okay, so we can see here we have different assets we mark along the line. Okay, we can see the first case is treasury bill. Because beta is 0, Ri equals risk-free rate. It is always 5.5%. Okay, so this is the intercept of SML with the y-axis. When beta is 0, we have this point here that Ri equals RRF 5.5 for treasury bill. Okay, for case 2, it is when for the markets portfolio, when beta is 1, Ri equals risk-free rate plus Rm minus Rf, and it becomes Rm. Okay, when beta is 1, we have this Rm, Ri equals Rm here, 10.5 for market portfolio. Okay, for high tech, beta is larger than 1, so Ri is larger than Rm. Okay, high tech is here, beta is larger than 1, so Ri becomes larger than Rm. Case 4, collectibles, beta is negative, so Ri is smaller than Rm. Okay, collectible is here, beta is negative, so Ri, okay, is smaller than Rm. Okay, so here is the security market line. Let's look at an example here. If we have equally weighted two stock portfolio with 50% invested in high tech and 50% invested in collectibles, we can find the beta and required rate of return for the portfolio by take the weighted average beta of the stock in the portfolio as the portfolio beta. And we take weighted average of the stock returns in the portfolio as portfolio return. Okay, for portfolio beta, it's the same as how we calculate portfolio return. We take weighted average of the beta or the return of the stocks in the portfolio. Okay, so in this example, we have beta portfolio equals the weights for high tech and collectible multiplied by the beta for high tech and collectible. Okay, so we have beta as for the high tech as 1.32. Beta for collectible is negative 0.87. Okay, weights is 50%, 50%. Okay, these two betas are estimated from our last video. Okay, it's here. So we are using it here. So the beta of the portfolio becomes 50% for high tech multiplied by beta for high tech, 1.32, plus 50% weight for collectible multiplied by the beta for collectible, negative 0.87. So we have 0.225 as portfolio beta. Okay, required rate of return for the portfolio, again, is the weighted average of the stock return. Okay, so for the return for these two assets, it's 12.1%, 1.15%. We multiply by 50% for each stock return. The portfolio return is 6.625%. Okay, this is how we calculate portfolio beta and portfolio return by taking the weighted average of the betas or the returns. Another way to calculate portfolio beta is to calculate excuse me, another way of calculate portfolio return is to calculate portfolio beta first and use CAPM model to calculate portfolio return. Okay, so instead of using the 2 returns of the stock multiplied by 2 weights to get the portfolio return, we can use the first step here to calculate portfolio beta as 0.225. Okay, and then we use 0.225 multiplied by the market risk premium 5% plus 5.5% risk-free rate. So portfolio return is 6.625%. Okay, we're using CAPM model. This is the same as the portfolio return as here.